Then the next one is a Corey-House reaction. So, here coupling of alkyl halides with organometallic compound happens. An alkyl halide and lithium dialkyl copper reacts together to give a higher alkane. To decrease the because alkyl lithium compounds are highly reactive. So, to reduce their reactivity, the alkyl lithium reagents are converted into copper derivative, that is to form the Gilman reagent. So, these are much less reactive compared to alkyl lithiums. So, this reaction, the condensation of alkyl halides with dialkyl copper lithium gives the R prime condensed product, that is alkane along with alkyl copper and lithium halide. So, this reaction can be used to prepare unsymmetrical alkanes. So, in the previous cases what we saw with lithium aluminum hydride reduction or other cases, we only removed the halogen atom. So, that means the starting material is the only thing which is getting converted into the alkyl halide is converted into alkane, but here we can actually do a coupling reaction. That means, two units can be combined to form a larger unit. So, this is what is the advantage of using Corey-House reaction. So, this butyl bromide is converted to butane. What happened was, here we only removed the halogen atom. So, that means, the starting material has n number of carbon atoms and the final product also has only the n number of carbon atoms. So, that means, we cannot add any extra carbon atom to the chain. So, this is one of the limitations of the previous methods like lithium aluminum hydride reduction or zinc and acid reduction. So, many of these methods will end up with only the n number of carbon atoms from which we started. But this Corey-House reaction actually adds additional things. That means, if we have 2 units, we can actually have a extra, that means, we can make unsymmetrical alkanes. So, if this is n and if this is n prime, so we can add n and n prime to get n and n prime alkanes. So, that means, we can actually add more number of carbon atoms. So, Corey-House reaction is one such example where we can extend the alkyl chain to higher alkanes, and the only limitation here is the n prime whatever we are using, that is the alkyl halide we are using, should be a primary alkyl halide. So, here is an example, we have a ethyl chloride. So, this ethyl chloride is converted to lithium derivative with the help of lithium, and copper iodide is added to this to get the lithium diethyl copper reagent. This is much less reactive compared to ethyl lithium, and this is then treated with the corresponding, we have 1 5 plus 1 6 plus 1 7. So, n is equal to 7 here, that means, heptyl bromide is added to ethyl halide, ethyl chloride to give nonane. So, that means, 7 plus 2 we could add to get the total 9 carbon fragment. So, this is the advantage of using Corey-House reaction. Here we can actually extend the alkyl halide chain. Let us look at how to prepare 2,2-dimethyl heptane. So, here is a method by which we can prepare the 2,2-dimethyl heptane. So, the tertiary butyl chloride is converted to the corresponding lithium derivative, followed by treatment with copper iodide gives the corresponding copper lithium derivative. This is then treated with n pentyl bromide to get the 2,2-dimethyl heptane. So, this is another method where we have a unsymmetrical. So, this part is having a tertiary butyl unit, this part is having a n pentyl unit. So, we have a unsymmetrical alkane, and this unsymmetrical alkane can easily be prepared by the Corey-House reaction. So, this is the advantage of using Corey-House reaction. The next we will move on to the Wolff Kishner reduction, which is a carbonyl reduction. So, basically carbonyl compounds, here we have a ketone R and R, two alkyl groups are present. So, this is a ketone, and it can be a ketone or aldehyde. If R is equal to hydrogen, that is aldehyde. If R is equal to an alkyl group, that is ketone. So, we can have a ketone or aldehyde, which can be treated with hydrazine to give the hydrazone derivative as shown here with the loss of water molecule. And this when treated with the hydrazone when treated with the base, that is sodium ethoxide, and heating at 200 degree centigrade leads to an alkane and loss of nitrogen gas. So, in other words, what we can what is happening here is this particular oxygen is completely removed as water molecule, and we end up with the hydrogen atom which is added here. So, that means R CH2R. So, this is the final product what we are obtaining. So, to convert or to remove the carbonyl oxygen, Wolff Kishner reduction can be employed. So, this is a simple way of understanding the reaction, and instead of hydrazine we can also use a semi-carbazide. So, an aldehyde or ketone when treated with a semi-carbazide gives a semi-carbazone. This semi-carbazone again on treatment with a strong base leads to the formation of an alkane. Here nitrogen and carbon dioxide are released. So, the overall reaction occurs very effectively because some of the products in the reactions are gaseous product. So, this reaction happens very effectively, and the formation of hydrazone and semi-carbazone is also used as a derivatization for carbonyl compounds. In the practical experiments, when you are doing a carbonyl compound, we generally use hydrazone and semi-carbazone as the derivative for preparing. So, the same derivative can be converted to the corresponding alkane by treatment with the base. So, the loss of nitrogen or carbon dioxide gas is the driving force for the alkane formation, because these are gas. So, they escape from the system. In other words, the product is formed very easily. The next one is mainly the advantage of using Wolff Kishner reduction. Say for example, if we have to do prepare some alkyl benzenes, we can use a Friedel-Crafts reaction effectively. So, benzene when treated with alkyl halide in the presence of AlCl3 gives the propyl benzene, but one of the disadvantage for this reaction is other products, and when this alkyl halide if leads to a formation of a carbocation. So, if the carbocation undergoes is possible to undergo rearrangement as shown here in this particular case, we end up with a mixture of product. And another important drawback is when we add an alkyl group to the aromatic system, this is being activated. So, instead of getting a mono substituted product, we may end up with a poly substituted product also. So, these are some of the disadvantages of using AlCl3 for the preparation of alkyl benzenes. But if we use the Wolff Kishner reduction, that means if we do the same Friedel-Crafts reaction using a acyl halide, then this acyl unit is a deactivating unit. So, the poly substitution will not happen on this aromatic system, and we end up with a acylated product, and this acylated product can easily be reduced using Wolff Kishner reduction to the corresponding alkyl benzene. So, this is one of the reason in many laboratory preparation people avoid the Friedel-Crafts reaction of alkyl halides directly, but they use one additional step of converting acyl benzenes to the corresponding propyl benzenes or similar compounds, alkyl benzenes.